Dictionaries are just a data structure that holds a one-to-one mapping of data. They're similar to hash maps or hash tables in other languages. In Python, you can initialize an empty dictionary either using curly brackets or the dict constructor. The curly brackets are the recommended way because it runs faster and also is easier to read. Here I have a dictionary called person, and it has some information about that person. His name is John, age 30, and he lives in the city of Palo Alto. I could alternatively use the dict constructor and pass these keys and values in this format. Another way that I could do it is by passing a list of tuples. So all these three are equivalent, but normally you see this first format because it's easier to read, and also currently we don't need to convert a data structure to a dictionary. If you originally had a data structure like this, then it would be easier probably to just use the dict constructor and convert that data structure. Now, the way that you access different keys is by just putting the key in brackets, and that way you can get the value. So this will return John because I'm accessing the name key. You can also add additional key values to your dictionary. Here I'm adding information about the state that this person lives in, and the key and value got added here. You can also update the values. So I already have the information about city, but I want to update that city from Palo Alto to San Francisco. So I just put the key value inside brackets, and I put the value that I want to update on the other side. So now city is updated to San Francisco. And currently I'm using strings and integers, but you can use any data types. So here I'm adding another key value pair, but my value is a list of strings. So that really is not an issue. You can have anything that you want as the value. Similar to sets and lists, you can also get the length of a dictionary, and that's basically the number of keys that you have. So here I have 1, 2, 3, 4, and 5. Although the values can be anything that you want, the keys have to be hashable, and only immutable data structures are hashable. Immutable just means they can't change. Basically, any data structure that can change is not immutable. For example, a list can change. You can append items to it. You can remove items from it. So that's not immutable. But a number is a number, or a tuple is an immutable data structure. You can't add or remove elements from it. So here, if I want to use first name and last name as my key, I cannot use a list because list is not hashable, and that's what Python is telling me here. Instead, I could use a tuple. So I have a few keys here, and each of them is a separate tuple, and that is okay. And the way that I would access it is similar to any other data type. So I'm just accessing this as a key. There are a number of built-in methods to interact with the dictionary. Here I'm starting from the person dictionary again, and using the get method, I can access any key. Here I'm accessing the name key and getting the value for that. It is very similar to putting the key inside brackets. There is a minor difference. Here, for example, I don't have a phone number. I don't have any phone number keys in this person dictionary. So if I try to access it using brackets, Python will throw an error. But using the get method, I could access anything, and if that key doesn't exist, Python will just return none. Optionally, I could also add an argument here to return in case that key doesn't exist. So right now phone number doesn't exist, so Python will give me that optional argument that I have provided to it. But if that key did exist, then Python will just give me the value for that key. So that's the difference between get and just putting the key inside brackets. There is a set default method in case you want to set a default for a specific key. Here I'm setting a default for phone number. So if phone number doesn't exist, then from this point on, any calls to this key will return this sentence. So even though I'm calling, basically I'm accessing this key using just brackets, because I have used this set default method and I've set a default for that key, then there is no error. We can also remove elements from a dictionary. Here I'm starting from the person dictionary again, and using the pop method, I can just pass the key to it and remove information about age. Notice that this is first returning the value for age and then removing the key value for age. Delete does almost the same thing, except that delete doesn't return any values. It just gets rid of that key and value. Another difference between pop and delete is that with pop, if the key does not exist, you have the option to provide this second argument to be returned, and so that way you don't see an error. So here, phone number, we know that phone number doesn't exist right now in this dictionary, and if I try to pop phone number, I can, because it doesn't exist, I just get this second argument. For both of them, if we don't provide this argument, for delete you don't have the option to, but for pop, if I don't provide this, I just get an error. Pop item is another method that removes an element from the dictionary, and from I think Python 3.9 and up, because insertion order in a dictionary is guaranteed, pop item will just remove the last element that was inserted to the dictionary. In the older versions of Python, pop item will just randomly remove an element from the dictionary. So here we only have name, so that would be removed, and now our dictionary is empty. You can also combine information from 2 or more dictionaries using the update method. Here I'm starting from that same person dictionary and getting the information about John's phone number from another dictionary called John. So here I'm just passing John to the update method, and if I print person, you see that now the information about John's phone number is also part of that person dictionary. You could also use the pipe operator from Python 3.9 or newer, but in the older versions, this operator does not do anything for dictionaries. There is a common mistake that some people make when working with copy or clear, and I'm going to try to clarify that. So here let's say I'm starting from person 1 dictionary, which is John and information about John. Now John has a twin brother, his name is Jim, and I look at this dictionary and I'm like, okay, everything in this dictionary is what I want for Jim. I'm just gonna copy that over and change the name. So I assign person 2 to the same dictionary and just change name for person 2 to Jim. So let's see what that will look like. Now if I print person 1 and person 2, I see that I have somehow changed the name to Jim for both people, and that's really not what I intended to do. What I really wanted to do was to take a copy of that dictionary. So instead of assigning these values, I wanted to copy, basically clone that object, and let's run this now. Now I have that first person, that's John, and the second one, that's Jim. So what is happening behind the scenes is that in the first scenario, I'm just adding another variable that is pointing to the same object. So when I change John to Jim, that is changing for both person 1 and person 2. In the case where I use copy, I am cloning that object to a separate one, and when I change John to Jim for person 2, that is not impacting that first object. A somewhat similar scenario applies to clear. Basically the difference between working with the reference or changing the object itself. Here I'm starting with the person dictionary, and because that's the information about John, I am temporarily assigning the information to a variable called John. So now both person and John have this same information. Now if at some point I want to discard all the information about John, if I just assign person to an empty dictionary, you see that person is now empty, but the variable John still has all of that information there. If I wanted to completely get rid of all that information, I would need to do it on the object. Here person is just pointing to a different object, therefore it's pointing to an empty dictionary, but John has information. If I use clear instead, so let's start from top. So person and John both have this information, and now I'm just calling clear on the person variable. But if I print out both of these, they're both empty because clear will actually go and perform the operation on the object. It's removing every element from the object itself. There are a few different ways to iterate over a dictionary. Let's say I want to make it easy for myself to access different colors. You know that in HTML, different colors have a hex value associated with them. And I don't want to memorize these hex values. I am interested in a certain shade of yellow, red, and blue, and I just want to, refer to them by the English name. So if I have this colors dictionary, I can get the hex value of red by just, calling colors and passing red to it. When you're working with a dictionary, using keys, you can get the list of the keys that you have using values. You can get the values that you have, and you also have the items method, which gives you the pair, basically a list of tuples of key and values. And that's how really you would iterate over a dictionary. You would use one of these. If you just use the for in format, so for color in colors, that's basically going over the keys. So I have yellow, red, and blue. You can similarly, you can pass the color to the dictionary using for in format to access the value. So the only difference here is that I'm passing the color, so yellow, red, and blue, to the dictionary, and I can get the hex value for them. Now, if I wanted to immediately access the key and value, then I would use the items built-in method, which returns two values. So up here, this is what items is returning. For each iteration, it is returning the key and the value. So my key is the color name and my value is the hex for that. And I'm just printing them out. So as I mentioned earlier, in Python 3.9 and later, insertion order in a list is guaranteed. This is not true for other languages that work with hash maps or hash tables, but in Python, this is currently a feature that's been added. And because of that, you can use this reversed function to basically start from the last element and basically last element that was inserted and go backwards. It's not a very common scenario to use that, and especially if in an interview you have a use case for this, you most often are asked to create a linked list or something of your own as opposed to relying on what Python provides. But it is always good to showcase your knowledge of this specific language in case you're using Python in an interview. So here I'm going from the last element, blue, red, yellow, as opposed to yellow, red, blue. Last item inserted backwards. Similar to sets or lists, we also have dictionary comprehension. You can create a dictionary dynamically using a for loop in this format. So here my key is the number and my value is the square of that number. And I'm generating the square values for numbers 2 to 10. So now if I want to get the square of 4, I can just easily pass 4 and get the square value for it. If I want to change this to only get the square values of numbers that are even, I just add an if condition here. So if I modulo 2 is 0, and now I only have the even values. It's a very useful technique if you want to dynamically generate a dictionary. One of the most powerful features of a dictionary is that you can nest dictionaries inside a dictionary as however many layers as you want. Here I have a 2-layer dictionary, and maybe I'm interested in different shades of a color. For example, for yellow, I want to have a light and dark, same thing for red, or for blue, I just want one color. But if I wanted to break that down even further and have, for example, for light yellow, I wanted to have 3 different shades, I could. And the way that you access them are very similar to how you would access a 1-layer dictionary. Here I am accessing the red keyword, and then from there I'm accessing the dark key. And this will print this value. You are well on your way to learn all the important built-in data structures that Python offers. If you are preparing for interviews, take a look at the question that I've written for you in the description section. Best of luck.